Hey everyone, so in today's lesson, we are doing lesson 1-3 and we are going back to combining like terms. So in this lesson, our objectives are to express an expression in simplest terms by combining like terms. And our language objective is to explain the process in our own words when we use combining like terms. So let's take a quick look at our do now. And for today's do now, we want to simplify each. And I am going to make you guys pause this video and try these 3 problems on your own. Okay, so what you should be doing for number 1 is distributing. So I'm going to distribute that 6. 6 times n plus 6 times 7, which will give me a 6n plus 42. For number 2, same thing. I'm going to distribute that negative 4. So I have negative 4 times 5a minus 4 times negative 3. And this is going to give us negative 20a plus 12. And then last one, we're going to apply distribution as well. And we get 3/4 times 4 minus 3/4 times 8x. So what happens here, if you put this in your calculator, but a little trick is when you're multiplying fractions, and if you see the same number, they cancel out. So you're left with 3 minus, and then when you're multiplying a fraction with the number, what you could think of it is as this 8 divided by this 4, giving you a 2. So this is 6x. This is the trickiest one, and this is where we would really want to use our calculators. So let's look at our thinking question for today, or thinking for today. It says, what are like terms? How do we combine like terms? So like terms are terms whose variables and exponents are the same. So in order for something to be considered a like term, they must contain the same variable and also the same exponent for me to put them together. So I put together some steps for combining like terms. I say draw lines in front of each positive or negative to separate each term. Color all like terms the same color. Put each group of like terms together and simplify each group. So I'm going to do this using my steps, and then I'm going to see if we could use a shortcut. So before I do that, let's give us some like terms. So we have like terms. Let's say I gave you a 3a to the second and a 4a to the second. Why are these like terms? Because they have the same variable, but also the same exponent. So I'm able to add them. I'm able to subtract them. Let's say I gave you a negative 5b and a 3b. Again, these are like terms. Why? Because they contain the same variable and they also contain the same exponent. Don't forget, if you don't see an exponent, what exponent's really there? An invisible one. So I'm able to combine them, adding or subtracting them. So let's take a look at our first example. All right, so for example 1, we are going to be combining like terms, expressing each in simplest form. So we are going to start off by separating every single term. So I'm going to draw lines where I see a positive or a negative, a subtraction or an addition. So those are my terms. I have 4 terms here. Right now I have 4 terms. So now let me color code the same terms, like terms. So I have an A here and I have an A here, and that's it. So I'm going to put those A's together. So I have a 5a, negative 5a plus 3a, and I'm going to bring negative 4b and minus 2 down. So I'm putting my like terms together. If I add these up, I am looking at the coefficient, the negative 5 plus 3, giving me a negative 2, same variable, a. When you're combining like terms, the variable and or exponent that you have stays exactly the same, and everything else is going to be dropped down. So here is my final answer because I cannot combine any further. So let's do number 2. Same process. I'm going to separate everything So I see how many terms? 1, 2, 3, 4, 5, 6 terms here. And I first look at this, I have 6 terms. Once I combine them, I'm going to most likely have fewer terms. So let me find like terms. I have a G here and I have a G here. So that means they're like terms. I have an H here and I have an H here. So those are like terms. And I have an X here and an X here. So those are my like terms. So I'm going to put all of my like terms together. So let's start with the G's. That 12G plus 11G. That was my pink highlighted. I'm going to do my orange. So I have a positive 5H, positive 9H. Those are my H's, my like terms. So I'm putting them together. And I have a negative 7X and a negative 4X, and I'm putting those together. So now I'm going to actually combine them. 12 plus 11 gives me a value of 23G. Positive 5 plus 9 gives me a value of positive 14H, and then we have a negative 7 minus 4 giving me a negative 11X, and that is my final answer. So I started off with 6 terms and my final answer only has 3 terms. The reason they came having fewer terms is because we had to do some sort of combining like terms. All right, so I'm going to do number 3. I'm going to start off by separating my terms. Okay, so I see 1, 2, 3, 4, 5 terms here. I'm going to highlight like terms. So I have a X and an X. Be very careful because I see an X to the second. But remember, like terms must have the same variable and the same exponent. So we could combine those two. And I'm going to rewrite them, putting my like terms together. Let's put the X's together first. I'm going to put my X squares after. And I'm going to drop down that positive 3y. So now let's combine. We have negative 2x plus 6x gives us 4x. Negative 4x squared minus 1x squared. Don't forget there's an invisible one there. Negative 5x squared plus 3y. So you guys try number 4 and let's see if we end up having the same like terms. So pause the video and try it out. I started off by separating my terms, highlighting my like terms, and combining it. Now, I do want to tell you guys something here. Here, I had only x's, right, as my variable. Even though they had different exponents, I put the variable with the highest exponent in front, just because we do want to start writing our answer using this standard form. But for right now, our goal is to have correct combining like terms. So we're going to stress writing our expression in a certain way a lot more, but I do want you just to get in the habit of combining correctly. So let's take a look at the next page. Okay, so for here, what we're doing is we're going to be finding the perimeter of a given shape. So this takes us back to combining like terms, but we're dealing with perimeter. So let's just define what perimeter is. The perimeter of a shape refers to the outside. That means in order to find the perimeter of a shape, we need to add the outside of that given shape. So let's do example 2. In example 2, they want us to express the perimeter of the given shape in simplest form. In this shape, I have 1, 2, 3 sides. All 3 sides are represented by some expression, right? That blue side I highlighted is x. The green is 3 minus 2x. And the pink is 7 plus x squared. So in order for me to find the perimeter, P for sure, what we're going to do is add all the sides, all the outside. So we have x plus 3 minus 2x plus 7 plus x squared. And at this point, for me to add, I'm going to take what I did before, highlight my like terms, and put them together. Now, without me rewriting, I'm just going to go straight to the answer. So I see that there's only x's involved here. So I'm going to get in the habit of writing my answer in standard form. So that means x to the second is going to come first. When I combine my x's, I get negative 1x. When I combine my constants, which are my numbers, I get positive 10. And this is what the perimeter is equal to. Let's try number 2. So in number 2, I have 4 sides. This is a square, and let me tell you why. These little markings are telling me that these sides are equal or congruent, to be exact. So I'm going to rewrite that 8 minus 2x on that side. If those sides are equal, that means all sides must be equal. So I'm going to rewrite that everywhere. So I have all 4 sides are equal to 8 minus 2x. My perimeter is equal to 8 minus 2x plus 8 minus 2x plus 8 minus 2x plus 8 minus 2x. So I'm adding all 4 sides. I'm going to start identifying my like terms. This time I'm not separating by lines. So I combine all of those. So when I combine all of my x's, how much do I have? Negative 2 minus 2 minus 2 minus 2, negative 8x. What about if I combine all of my constants, my 8 plus 32? So if you want to break it up like we did before and rewrite it so everything is nice and neat, you can do that. But I want us to try to do combining like terms without showing so much work in between. All right, let's go to our last 2 problems. So I have here a trapezoid. This is known as a trapezoid. I'm highlighting all my sides. They're all different. There's no markings telling me that their sides are the same. So I am going to start off by writing my perimeter is equal to 2x squared, 6y squared minus 5xy, plus 3y squared plus 6xy plus 4x squared. So that's a long one. I am going to identify my like terms. So I have x squared here and an x squared here. I have positive 6y squared, positive 3y squared, and then I have negative xy and a positive 6xy. So they're exactly the same. So now I could combine these. For this one, I'm going to, there's no specific order because there's so many different variables here. So I could write my answer as I want. So I'm going to start with the blue highlighted piece, my x squares. I'm going to go pink next. And I'm going to put that xy last. And there is my final answer. If you want, you could always put the invisible one in if it makes you feel a little bit better. That's okay. I normally won't put it there because I know that there should be an invisible one in there. But if you like seeing it, you can. All right, so for number 4, again, I see these markings. So I'm going to highlight those 2 sides exactly the same color. And then these sides are different. So those markings always tell you that the sides are equal in length. So they have the same exact measurement. So in this case, in terms of y. So let's start by writing p equals 1 minus 2y plus y squared plus 3y plus 1 minus 2y plus 8y squared. I'm going to highlight my like terms. So I have a 1 here and another one here. I have a y here, so negative 2y with the positive 3y with the negative 2y. And we have y squares that can be combined. So now I am going to write my answer. And notice here, we only have the variable y. So I'm going to try to write my answer in the correct form, standard form. So let's put the highest exponent first. Which y has the highest exponent? The y squares. So I'm going to add those 2 together, followed by y plus 2. Let's just review a quick summary of what it is that we did. So we have combining like terms is an important step when we are asked to simplify an expression. We can use our knowledge of combining like terms for many things in algebra, like finding the perimeter and solving an equation. We still have not solved an equation, but we're going to need to use this basic skill to help us solve an equation. It is important to learn this important skill. So keep learning, keep growing, and I will see you in the next video.